Today is going to be packed with a lot of great conversations, a lot of great technology, a lot of great networking. But we're going to go ahead and keep things moving. Up next is an amazing panel of end users, integrators, people with many, many years of experience. And really what we're going to be talking about today is smart manufacturing technology beyond the buzzwords. We hear a lot of buzzwords in the industry, and our goal is to talk about how we can change the industry and what great technology we're using right now, where it's not just one of those things where we talk about it, we're actually using it. I'm gonna go ahead and welcome to the stage, I'm just gonna go over here, Mike Stevens. He is the Digital Solutions Director at CBT. Mike, come on up. After that is Kasey Jastrzembowski. I got that right, silent Z, the Global PC&IS for Cybersecurity at Procter & Gamble. And then finally, we have Matt Feldhues, who's a senior engineer at E-Volve Systems. So come on up, guys. Perfect. Well, thank you so much for being here today and having this conversation. We had a great conversation a couple weeks ago, in fact, just talking about it. And we had an idea and a conversation we wanted to roll with, but when we started talking about AI, and we kind of just stuck on that for a little bit and how companies can use AI, great examples of it. So we're going to dive into that. But first, let's go ahead and let you just introduce yourselves. Tell us about your background, a little bit about what you do at the company. Matt, do we want to start with you, and then we'll just go down the line?
So yeah, Matt Feldhues. I've been with, well, we were acquired by E-Tech Group a while ago, but I guess in total 8 years now. And my role there is, it says I'm a senior engineer. I'm doing a lot of account executive stuff, business development stuff, and really just mapping this industry onto the needs of clients and a diverse skill set across North America to try to meet those solutions. So as we get into digital transformation stuff, AI is something we're working a lot on.
Awesome.
Hello, everyone. Kasey Jastrzembowski. I have been with P&G for 15 years. I started doing a lot of different controls projects in baby care for the first 7 years of my career. Now I am our global, we now call it intelligent controls and automation leader for FemCare. I also have cybersecurity and then a lot of the IT/OT digital work that we're expanding globally across our manufacturing sites. Excited to be here.
Hi, I'm Mike Stevens. I'm the Director of Digital Solutions at CBT. Been with CBT for about 6 years. Prior to that, I was with Wire and Cable Company, General Cable, for 17 years, all manufacturing industry, IT throughout my career. So I'm the IT representative here, I guess, in the OT world, right? So happy to be here.
Awesome. So we kicked off the keynote when I talked about just Morgan Freeman doing an AI thing, and that's, it's fun, it's playful, but in manufacturing, we want to know how is AI actually being used in our industry. And really I want to kick this off with Kasey first. Your company is massive. You've been in the industry for a long time. You're a leader within the company. How did you begin to use AI? Like, what was the introduction of AI for you at the company? And then how are you currently using it today, and what does that look like?
Sure. So we started looking at AI as an opportunity to gain value, right? So everything we're doing, we're trying to figure out, what new technologies we can use to continue delivering value across our business. For us, the big use case has been around quality and how we can use AI and ML to continue delivering perfect quality, which is one of our prerogatives at P&G. And then from there, it's been amazing how it's expanded. I think once we found a way that we could successfully integrate it and we could deliver value to our customers in manufacturing, suddenly we had all sorts of plants and use cases and people excited about it. So we have continued to spread and we continue to work towards continuous value driven by the technology.
Yeah, and just to add to that, I think just like we talked about last week or a couple weeks ago now, time flies, is, we talk about AI and it might seem like a black box, right? But when we talk about AI today, it really is just high-level statistics, right? They talk about artificial general intelligence, AGI. They estimate 2030 maybe before we hit that. But today, it really is statistics. And I think one of the things that we can do to start driving towards that is making our data accessible, right? Because the statistics or the AI that we have today is 100% reliant on quality data. and being able to surface that data from that very low level in the Purdue model all the way back up to the enterprise, right?
So, Michael, next question is for you on this one. What do you need as really a foundation before you begin the process of even smart manufacturing? I mean, smart manufacturing is a buzzword, digital transformation, the automation roadmap, right? I worked for a systems integrator for 3 years where all we did was deploy SCADA, MES, CMMS. Where do we start when it comes to creating the foundation of smart manufacturing?
Yeah, it really, you start with just an assessment, right? Where are you today? Where are you at in your digital journey? Where do you want to go, right? And it's just like taking a car ride and putting on a GPS. You're here today, where do you want to go? And then trying to figure out the steps that you need to drive towards that vision, right? And so we typically start out with doing an assessment or identification of where you are today and what you've got, what tools are at your disposal, and then trying to basically bolt onto that and step forward towards that digital transformation, but just in small chunks, right? So.
Matt, or Kasey, anything you want to add on to that?
I was going to add, I think that for us too, we've realized how much power's in the data, like you were saying a moment ago. So even starting to collect the right data that's useful to the end users, and as much as displaying it in a way that's really useful, then once you start getting the data, you start building value out of it, then you start doing fancier things with it. All in all, kind of on a continuous growth mission. But it's been hard when you try and jump straight into something, you gotta kind of work your way and make sure that you're building the rapport as well along the way.
Yeah, so what we see, going to hundreds or thousands of different client sites in a year is everybody in manufacturing is on a spectrum. They have some new stuff that they are collecting data from that is connected with Ethernet to a OT network, and they have some virtualization on that platform. And then they have other stuff that's obsolete. They have some SLICs. They have some PLC 5s. I saw a PLC 2 earlier this year. Chad's laughing. They're out there. And when we talk about that spectrum of manufacturing intelligence, what we're doing most commonly in those places is trying to add systems that we can then bolt on higher level manufacturing intelligence to without going backwards. So when we're talking about data, there are lots of systems where the process is monitored by Johnny Clipboard and SneakerNet, and we either have some island of automation that we have to put a USB stick in or a thumb drive or go pull an SD card from once a week or once a month or on whatever frequency to get that data. Or even worse, it's a fully manual process and we're fully reliant on handwritten batch records or Johnny Clipboard. They're writing down, this is what happened during the process, and I observe these gauges. And AI is like a million miles away from that. And what we're doing is, how do we add, what are the right places, most bang for your buck, to add instrumentation or connect those systems in the right order so that at least you have the data then and you can start making decisions about how to contextualize that, how to put that in the hands of the people that are going to make decisions about quality or making process better. And then AI, if we get enough data, we can build a model around that and then train, this is what ideal process looks like versus variance. So there's this whole spectrum that we're trying to make more uniform so that these emerging technologies are capable of using the equipment that you have now or bolting onto that equipment.
So to add on to that, and Matt, I want you to answer first, and I want to go down the line here. When we look at AI, a lot of people use it as a tool, but it's got to be different between a small to medium-sized business and a large enterprise-level company, right? There's no way that companies can invest the same way that a multi-million or multi-billion-dollar company can if a small machine shop or a small manufacturer wants to do it who has maybe 100 or 200 employees. How is AI different? And then how is AI used the same between those two levels?
So for a large company, I'll use P&G as an example versus a small company that maybe has one site, like you were describing. They have 20 manufacturing lines, a few hundred employees, and they're very localized. The great thing about AI is you don't have to have this technology on-prem. You can, if you can get the cybersecurity piece right, you can get that data into a cloud environment where there are resources available to you that you couldn't, as that small manufacturing facility, justify purchasing. You can lease, almost like a lease, that computing power and that technology in that environment. So think about it a different way. When computers first came out, we're talking about NASA, and it's like a computer room the size of this, and it's one computer. And then over time, very rapidly, everybody in this room has a computer in their bag. That's a much shorter runway with this stuff. If we can get the data to a cloud environment or with access to the computing resources to deal with it, it's accessible to small and medium-sized manufacturers as much as it is to P&G.
Awesome.
I guess in my perspective, it depends a bit on the use case, right? So we have some plants that have specific needs that are really intended for that site, and then we have some use cases that we are scaling globally. In either event, you need to make sure you kind of understand the requirements. Is it something that's going to impact my business if it shuts down or it does the wrong thing? Is it something that's going to that it's okay if there's one person who knows how to keep it running, and if that person's on vacation, we shut it down for the week, we shut it down for the week. And then, making sure that you have the capability and then the resiliency for the use case that you need. So for us, we have, like I said, some things that are smaller, more localized solutions. We have some things that are scaled much broader. And then I do agree to your kind of security point. I would add IT resiliency, but I think it's really important as we're investing in these things, we understand what the business requirements are, and that we don't just, run away saying, oh, we did this and we saved all this money, and then we have something that we can't support and manage and maintain ongoing either. So yeah, I think there's different investments required for different scaled solutions, and then we're kind of always trying to figure out what things make sense to scale and to continue investing in across the globe for us.
And just to add to that, right, so you certainly have the cloud, right? The cloud enables small, medium, and large companies, right? But even without leveraging the cloud, there are some open source tools that you can leverage that can take very, high level statistics and apply that to your data. We did a small proof of concept project where we took vibration analysis data, ran it through some Python code, and did anomaly detection against it, right? So it is definitely plausible. It's just a matter of, like Kasey said, your use case and how you want to apply that.
Can you dive into that more? Can you talk more about some use cases? I know you mentioned vibration analysis as one of preventative maintenance as another one. Yep. What are some examples of, hey, this is how we're using AI right now, and these are the results that we've seen?
Sure. So, quality is certainly something that is definitely, I could see a use case, and you could probably speak to that better than I can. But preventative maintenance, again, like Matt was saying, you can take it, you can use that and say, here's the good data, here's what it looks like, gold standard, right? And then as you apply that learning to that data, regardless of whether it is, we used vibration analysis as an example, but regardless of the data set, you just train that, and then it would basically spit out the, hey, this looks like there's an anomaly, there's an issue here, right? And then the more anomalies you see, okay, well, there's something really going on here, we need to take a look, right? And so it does help drive closer to that predictive maintenance that we really all are striving to accomplish, right?
Yeah, and I would say, we're also doing a lot of anomaly detection for quality. We've always had traditional rules-based capability, and there's a lot of wonderful capability out there, but as we've started doing more and more anomaly detection, we find that AI is a better tool to do that. And then also, that opens up some of the things we can consider doing as well as part of our product glide path, because we have more and more ability to look for and detect different things, and also for some of our consumer feedback, et cetera. So a lot of great capability with anomaly detection today in AI, and then continuing to look at what we can do for preventative maintenance type use cases and all of the things that we want to use as part of our PR glide path for our sites.
So I want to dive in a little bit more with Procter & Gamble's approach to smart manufacturing. Was that anomaly detection like the initial thought process of how you would leverage AI, or did you arrive there through multiple steps? Like, was that your initial goal, or did you have a different path that you guys wanted to go for, and you just kind of manage to find that as a solution that you wanted to run with?
I think it's a little bit of a give and take. I don't know that it's really a clear answer. For us, we had specific product requirements that we were looking to get better about detecting. In the meantime, we continue to investigate technology that's available on the market and technology that, we work on progressing in-house. And then we were able to kind of find a sweet spot. And then what's been, really exciting for me is as we have found that sweet spot, more and more people come with more use cases, right? So, it was a little intimidating at first. Is this really a good idea? Like I said earlier, if it breaks, is, Jimmy going to be there who knows how to fix it, or what are we going to do about it? But what we found is that as we have more capable technology, in fact, we need less management and maintenance on it. And then, that's continued to help our journey of people wanting to do more and more use cases. So it's a little bit of a give and take. I don't think it's necessarily a clear path forward, but yeah.
So kind of the takeaway from that is you have to be flexible. And I think a lot of times when we're going out there and we're creating this smart manufacturing goal, oftentimes we create a finish line that we want to achieve. And I think a lot of times smart manufacturing projects fail in a lot of cases because we're not moving that finish line depending on what we're learning along the way. Is that what we're seeing and what you guys saw as well, where, hey, maybe it's not even the initial finish line that we thought we were going for, but when we hit a big wall right here, we realize that, you know what, we see this door open, maybe we're going to move to a different path.
I like the term digital evolution.
Okay.
Right, as opposed to digital transformation. Transformation, you can kind of take that two ways, right? You can transform in a good way, you can transform in a bad way. In some cases, it fails, right? But digital evolution, it has a nice connotation to it because you really are evolving, right? And as you're moving forward, you're shifting and adjusting, and whether it's AI or any other tech, you're shifting and changing your process, your people, along with that, right?
Matt, so going back to you, what are some of the biggest challenges that your team has come across when you're looking at integrating smart manufacturing solutions into your processes?
So I think the number one challenge is, to go back to the spectrum that we were talking about, we have various life cycle aged equipment at Plant 4s and various levels of connectivity, and there is a resistance to change if something is working. So right now, you have a manufacturing line and it's been there for 20 years and it's just been doing whatever it does. And we're not really sure what the OEE is on that, but it's working. And I come in and do an assessment and look at it and I say, okay, well, we can change all this stuff and you don't have any data, and we can get you data and then your decision makers. And they're like, okay, but what's the ROI on that? And I'm like, well, I don't know, because I don't know what you're going to find in the data when you have it, and then it dies. Because you have to have an internal champion for projects like that can see over the horizon a little bit to get projects like that moving forward. The first thing that gets cut on every project is value add scope. So I have a PLC that's working, it's end of life. It's going to go out of support at some point in the future that Rockwell hasn't announced yet. But when it does, somebody's going to buy all those parts, and that stuff, okay, we'll deal with it later. That gets cut from scopes immediately, and so then you're limited by the technology and the data that you're collecting to try to advance projects like that. You have to have internal champions to get it done.
One of my favorite quotes was from you, Mike, when we had our meeting. It was, AI needs data. If you can't access data, AI won't be useful. Can we talk more about that? I mean, we often talk about smart manufacturing, but data's king. And unless you can act on data, I mean, you can collect all the data that you want, but unless it's useful, we can't do anything with it.
Right. Yeah, and again, what can you do today, right? Today, like Matt just said, right, the PLCs that need to be upgraded in order to collect that data are not being replaced. Well, that really is setting the foundation for everything in your future, right? So in order to improve your process, in order to drive and get ROI from quality, in order to leverage anything that is going to continue to make your company profitable, from a production perspective, you need to extract and get access to that data. Yeah.
Yeah, and like I said too, I think that there is an initial hurdle of having the data just present right there and available to use. I mean, so many different use cases where, hey, go around the plant and find all of these things and blah, 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 blah. Well, that's a waste of someone's time, right? Like, what data can we have and how can we summarize and share that data in a way that provides value to, the front line, and then you get more and more energy and excitement around the systems, then you get more and more application of them, more and more data, now you can start doing more and more things with them, right? So I think sometimes we have to be a little careful about how we evolve instead of transform, and taking some baby steps into, growing the energy and the excitement, and then as the excitement grows, then I think use cases start developing on top of it.
Awesome. So I'm going to call an audible in about 5 minutes. We didn't have this plan, but excuse me. If we could have a microphone ready, we're going to take a couple audience questions.
Right.
And I don't know, and I like this, so I don't know who could run around with that microphone, but I think it would be fun to have. One of the questions that I have is AI going to bring the separation of companies closer together with adoption, or is AI going to make it so it's going to be harder and harder to compete? I look at robotics as an example. For a while, robotics was only adopted by the really large manufacturers who are running, high volume, low variability parts. And in recent years, robotics has really been able to transform the industry and make it accessible to any people. So is AI going to be similar to that, or is it going to be different?
How much do you want me to geek out on you?
You got time. You got time.
I think it's definitely going to be a differentiator, right? Is it going to bridge the gap? I can't say for sure, right? But if you look at Figure 1, I don't know if you follow the humanoid robot world, but Figure 1 is one of the more prominent humanoid robots that are out there. I think they're doing a prototype at BMW's facility. And what's interesting about that humanoid is it's not programmed. It watches a video of somebody putting and doing a process. In this case, there is a sample of putting a Keurig pod in a Keurig pod, right? Pretty simplistic. Could be just a regular robotic arm, but what's interesting about it is nobody programmed it. They played it a video, they used AI, and then the robot taught itself how to manipulate that Keurig pod, and it self-corrected and put it into the coffee pot, right? That is a huge differentiator, right? And it did it very, very rapidly. So that I think is definitely going to change the market.
I think the cost of entry is changing a lot too, right? So just like robotics, when it was first something we were all looking at, it was clunky, it was expensive, it was all the things. It's gotten much more elegant, it's gotten much easier, and it's gotten cheaper. I think we're going to see the same trend in AI, and then to the speech you made earlier, I think there's a whole young generation that we need to empower to help us change the way we're doing it. So, I mean, my last 2 interns walked in the door and they're like, I want to do AI. I'm like, oh, well, there goes that work plan. Let's go this way instead, right? But I think that there is a huge opportunity, and I think we need to figure out, how we can use the next generation to bring it, and that will, continue enabling everyone's path forward, so.
I actually think it's a really accessible platform. We, as E-Tech, look at this as the next, I don't want to say necessarily winnowing line, but this is going to separate people, not necessarily by size, but by people that are willing to adopt this revolution in this industry versus people that resist it for too long and they just get overwhelmed. And I don't think it's going to be cost barrier to entry that will do that. It's going to come down to, do I see over the horizon enough to say this is going to be really important, this is going to change the way that we're making things? And there's a lot of different aspects to that. It's quality, it's how do I have more replicable, faster, higher OEE in batch process? How do I troubleshoot discrete manufacturing process? How do I coordinate internal logistics in a factory, from resource manager getting the right person in the right place at the right time, prioritizing maintenance, prepping for maintenance, that stuff. But I also think it's some of what you were talking about in the keynote, where companies that embrace this stuff are going to be more attractive to the new workforce, and companies that don't are going to be less attractive, and they're going to get smoked. They're just not going to be able to attract the bright talent that's available, because they're going to go where people are making investments in technology that's forward-looking versus we just want to stay where we are as long as we can.
To kind of add on that with my own question, I view AI as a train. And right now, it's at the train station, and it's slowly going to start moving. And the sooner you hop on that train, you're already you're already with momentum with the train. And that train's going to continue to speed up, and it's going to get faster, and it's going to get faster and faster. And then it's to the point where it's very risky to hop on that train. You can, but if you can at least just get on it now and just figure out some small processes and steps to at least be part of that momentum, it's going to make your company a lot easier to implement successful implementation of AI and smart manufacturing solutions in the years ahead. Because I think AI in the next 5-10 years is really going to transform our industry. We're finding, I think, more use cases for AI than we thought when it was originally designed for. I think we're finding, hey, we're going to do this, but you know what? We found A, B, and C as a solution, as a better option than what we originally designed this, model to be around. So with that said, I know we have a microphone, and I know this is impromptu. I apologize to the team that I did not say I was going to do this ahead of time. Are there any audience questions, I guess, regarding smart manufacturing, digital transformation, AI? You have 3 extremely knowledgeable people in the industry who are working with it right now. Any questions in the audience? Man, must be a lot of experts. Okay, here we go. Good. I was going to say, man, we have more experts in the audience than we do up on stage.
All right. What is...
name and company, too.
Eric Roderi, Amen Consulting. We do consulting and manufacturing. What softwares are out there where clients can start utilizing today that utilizes AI to help transform their business or evolve their business over the next few months and years?
So there's a few different layers that we could talk about here. So there's edge devices where this is not cloud-based. This would be like vibration monitoring for large motors. If you have a motor, and kind of the threshold where I would say this is important is it a motor that if something goes wrong with it, you're going to send it to a factory and you're going to get it repaired versus getting a new one? So we're talking hundreds of horsepower, big DC motors, big AC motors, and the cost of repair is substantially less than just going, to CBT and buying a new one. Those are... Everybody has one. Rockwell has one. Most companies have something like that. The layer above that, when we get to cloud-based stuff, there's a lot of different applications that we can talk about to try to meet your use case. So Aviva, which is probably I'm not supposed to say at this, they have a lot of stuff for that. Rockwell is putting out stuff now that's, again, cloud-based, and it's subscription-based applications where we're looking at very finite use case. How are we going to apply some version of this? At the end of the day, this is really important. It is model training. It's not a human brain. It's not like some operator that knows pulp and paper really well, and they know when something is right or wrong based on the way that the plant smells, or they heard something, or they felt the floor shake a certain way. It's not a human brain. It's a computer brain. And so it's looking at a big pool of data and saying, this was good, this was bad. And when we can train it to your use case, then you start getting results. One other application, this comes in a lot, is we're trying to figure out how to do this, integrate this with AI now. But on the digital twin stuff, so probably everybody's heard about digital twins and what do they look like. We're using Unity software to develop digital twins. It's a video game software, very attractive to the new workforce because it's super cool. And if we can get a digital twin, then we can start replicating that data in a sandbox. It's not the actual manufacturing floor anymore, but it looks like this, and we can play around with that with AI models. And we're still developing that. I would say that's kind of like the bleeding edge right now, but I don't know if that answers your question.
To add on to that as well, like when I look at other great examples of how AI is being used, machine vision has really done an incredible job adopting AI from I mean, pretty much every large machine vision manufacturer out there, either it's through Cognex's acquisition of VIDI a while back, Apera AI, MechMind. Almost every company out there is creating a vision solution that you create your own models, you put in a bunch of images, and it really has tremendously transformed the industry in terms of at least quality inspection. And really, you're going to find dozens and dozens of companies who have really done a great job with the AI side.
I was going to say machine vision,
Okay.
so you stole
Yeah.
my answer.
Perfect. And is P&G, are you guys using?
Yes.
Okay, yeah, as a great, can you talk about a case study or no?
I mean, I kind of already did, right? So there's a lot of machine vision solutions out there today for anomaly detection that are all helping us drive better quality in our products. So as you start getting into, things that are just different, right? As opposed to, is this long or is this edge here or there? There's a lot of really great products available in the industry today for machine vision inspections.
Yeah, and just, I think that's part of the challenge with AI today is the ecosystem is large. There's a lot of players. And, we could certainly leverage Azure. You could certainly, Amazon, Google has their own AI offering as well, right? And then you've got, ChatGPT. Everyone knows ChatGPT, but then there's Claude and there's Gemini, and we've even played with. There's open source tools out there. One of them is called AutoGen. It's by Microsoft, and it's the next level of ChatGPT, right? So ChatGPT, it's great. You give it a singular prompt and it answers, right? But think about multiple agents where you ask it a question and they all have specific tasks, and then they work on it like a human brain, quote unquote, and then return the results. And AutoGen is an open source tool that helps accomplish that, right? You can actually build multiple agents, give them specific tasks, and then the user asks for a prompt, and they go and call out to SQL, they call out to the different data sources, bring back the answer, and basically, hey, here you go, here's what we think, right? So a lot of different tools out there, but it is getting very, very sophisticated to train, right? And it's getting faster.
We had another question in the back or front somewhere. Can you raise your hand? Perfect. And then I think just to keep up on time and get us back kind of on track, we'll wrap up with this question right here.
Yeah, hi. Justin Green with Palmer Manufacturing. We make OEM equipment for the foundry industry. My question was primarily for Kasey. You mentioned how when you would implement a project, and then other people would see how that project could help them, and then how I'm assuming that just really snowballed. How did you handle that from the people working on the projects, but then also from the company perspective of how much did your department doing that sort of thing grow?
From a resource standpoint?
Yeah.
So for us, what we did is we defined a clear model of what was required to add new applications, right? So what do you need in the site? Who's your kind of first line of defense, second line of defense, then the experts that you need. And then we have a global leader who helps, call it consult on new applications is this really the right way to go? And then working with our regional resources and our platform resources, et cetera, kind of trying and testing and implementing use cases. But we have expectations on, what the first line of defense from a required support model is, so that we have, people in the plants where we're putting this technology who also have, an understanding and a capability, and then they know who to escalate to if they, continue to run into a higher level technical problem or concern.
Awesome. Either of you wanted to add on to that at all?
No, I think for any project, change management's important, right? So I think it's good to kind of keep that and that cadence and driving that forward. So yeah.
Absolutely. Perfect. Well, I think that is going to get us on time to wrap it up. So I really appreciate it. Mike, Kasey, Matt, really appreciate all you coming up on stage. If you have additional questions as well, I'm sure they'll be around for a little bit too. Feel free to approach them and ask more questions. But thank you for sticking around for this panel.